Okay, so this is quiz number 18. And again, we've got a switch circuit. So remember, for a capacitor, it's the voltage that satisfies this decaying exponential equation. So in other words, my voltage is going to be, V of t is going to be my final voltage plus my initial voltage minus my final voltage, e to the minus t over tau. In this case, tau is equal to RC, and this is R Thevenin times C. Okay, so we need to find the R, so the things we need to find are V final, V initial, and this R Thevenin, so we know the right time constant. Okay, so before time t equals 0, the switch opens. So before time equals 0, this switch has been closed for a long period of time. And after it's closed for a long period of time, this guy completely charges up, right? So it looks like an open circuit. So the voltage that will be the voltage it charges up to, if we were to think of this as an open circuit, it would be the voltage, in other words, if we were to ignore this guy, it would be the voltage that's across this 6 ohm resistance. So my V initial is just going to be a voltage divider. So it's going to be 12 divided across this 6 ohm resistance. So it's going to be 12 times 6 over 9. So let's see, so what's that? 12 times 2 over 3, which is 24 over 3, which is 8. So it's going to be 8 volts. Okay, now the final voltage, again, you assume that this circuit is open, and when this is open, there's no, we're not driving anything here, and so it's kind of like this part of the circuit is cut off because there's no current that flows in this direction. So we'll just basically discharge through these 2 resistors, and so the open once it discharges, there's nothing driving here. The voltage here will be 0. So my voltage final is just 0 volts. And after it's been open, what is the Thevenin equivalent? So again, what we're going to do is we want to look into the circuit, in this direction, but it's when this switch is open. So it's basically, that's cut off, and we basically have our 8 ohms again. So in this case, RTH is equal to 8 ohms, just like in the previous circuit. And so my time constant is going to be 8 times 25 microfarad. So let's see, times 4 would be 100, so this would be 200 microseconds. Okay, so now I can just write my voltage. The voltage is time t is going to be 0 plus 8 minus 0 e to the minus t divided by 200 micro. And that's going to be my voltage. Now, what will be the what will be the current? So remember, the current in a capacitor equals C dV dt. So the current is going to be C times, now I have to just differentiate this thing. So when I differentiate an exponential, I'll have my 8, and then I'll have the minus 1 over 200 micro, and then the same thing back again, minus t over 200 micro. And C in this case is going to be 25 microfarads times 8 divided by minus 200 microfarads, e to the minus t 200 micro. So let's see, 200 micro times 8 is 200 micro divided by 200 micro. So this is going to be just minus e to the minus t over 200 micro, and this is in amps. And of course, this is all for t greater than or equal to 0. This is t greater than or equal to 0. Okay, that is quiz number 18.